Laws of physics often enjoy a place of privilege and certainty. But every once in a while, a new study comes along that challenges, our understanding of these laws. Physicists from the West Virginia University have provided a novel insight into the first law of thermodynamics. This has helped us in expanding the scope and its explanatory power. The first law of thermodynamics, it states that the total amount of energy, which is present within the universe, it will always remains the same. So this is in accordance with the law of conservation of energy. And energy can neither be created nor be destroyed, and it can only be converted from one form to another form. So suppose that you heat up a balloon, then the first law of thermodynamics will tell you how much the balloon will expand and how much hotter the gas inside the balloon will get. Paul Cassak, who is the lead author of this study, he said in a press release that the key is that the total amount of energy which is causing the balloon to expand and the gas to get hotter is the same as the amount of heat you are putting into the balloon. The researchers' paper, which was published in a journal of physical review letters, it focuses on how the first law can be applied more widely than it was previously thought. See, the first law, it hinges on the fact that it is valid only in systems where the temperature can be defined properly. That is, the systems that can reach a measurable equilibrium. When hot water, it is mixed with cold water in a cup, then the mixed water will reach an in between and final temperature. So throughout the years, the first law has only been able to be applied when there is not much of a difference in the temperature between the system between the systems, and not when there is a large difference in temperature. But the new study, which attempted to remedy this by examining how energy can be converted, is in superheated plasmas in space. We generalize the first law of thermodynamics for systems that are not in equilibrium. We did a pencil and paper calculation to find how much energy is associated with matter not being in equilibrium. And it works whether the system is close or far from equilibrium. The researchers also realized that in order to apply the first law of thermodynamics more broadly, they needed to find a way, to quantify all the energy conversions that did not involve expansion and heating. And they did. The result represents a really large step to our understanding, according to Dr. Kasak. See, the development is theoretical but has potentially immense practical applications. A better understanding of the law will help astronomers to understand the plasmas which are present in the space. And so it will develop a better understanding of even the space weather, which, when goes awry, can affect satellite communications, and it can also trigger power outages on Earth. The team is also expecting that their work will also help other physicists also to understand the issues which are there in quantum computers and galaxy evolution in a better way. The new study is, seen as part of work which is being conducted at the phase space mapping experiment, which is also called phasma, conducted at in the WVU Center for Kinetic, Experimental, Theoretical, and Integrated Computational Plasma Physics.